Alright, so this next unit starts factoring. Factoring is just an algebraic method of breaking down a polynomial into the pieces that are multiplied together to make them. So sometimes a monomial multiplies times a polynomial to make a bigger polynomial, or sometimes two binomials multiply together. Sometimes it's just a number being multiplied. But when you break that apart, that's factoring. So there's several different types of factoring. The first one we're going to talk about is called GCF, or greatest common factor. This should always be the very first type of factoring that you're attempting. All other factoring should be done after this kind of factoring, or after this kind of factoring has been attempted and it's been proven that there is no greatest common factor. Now, it's going to sound it sounds like it may be something new and scary, but really you've already been doing this. It's the same as reverse distribution. So basically you're looking at the polynomial and you're taking a look and saying, is there anything that can be undistributed from every piece in here? So if we take a look at the first example, we've got 2x cubed plus 6x squared minus 8x. Well, I can undistribute a 2 from everything because all those numbers are even, so I can pull out a 2. And there's an x everywhere, at least one of them. So if I undistributed a 2x, okay, if I undistributed a 2x, I would put that out front. And then what would this look like before 2x had been multiplied in? What would look like x squared, because x squared times 2x would have given me the 2x cubed. 2x times what would give me 6x squared, and that's just 3x. And then 2x times what would give me negative 8x, and that would have been negative 4. So that is just how you pull out that one number that's, or that one monomial in this case, that had been distributed throughout the entire polynomial. You can always check by multiplying it back in. We kind of did that mentally a second ago. But the way you would do it is you could distribute that back in. This is something you've already been doing, or we have been doing for quite a bit now. So 2x times x squared is 2x cubed. 2x times 3x is 6x squared. 2x times negative 4 is 8x. Since this is what we started with, I know that this is the right answer. So the good news about this unit is that you would be able to tell what grade you get on the test by simply multiplying back through all of your answers to see if you can get what you started with. So some more examples. This one says a squared b cubed plus a cubed b squared. Now this is one of the hardest ones I can think of to do because it's so, it looks so odd having all numbers there, or excuse me, all letters and no numbers. But there's an a squared in both pieces, and there's at least a b squared in both pieces. So the a squared and b squared can both be undistributed. So when I pull out an a squared and a b squared from my first term, the only thing that's left is a b. And when I pull out an a squared and a b squared from my second term, the only thing that's left is an a. Again, I can check my work by distributing it back. A squared b squared times b is a squared b cubed. A squared b squared times a is a cubed b squared, which is what I started with, so I know that this is my right answer. Alright, so the next one, I've got 3x to the fourth, 6x cubed, minus 3x squared, plus 2x. So an x can certainly be undistributed because I see an x in every one of those. But as much as I'd want to pull out a 3 because I've got a 3, a 6, and a 3, the 3 can't pull out of the 2. It can't be undistributed from the 2 evenly. So we're not going to undistribute the 3. We're just going to undistribute an x. And when I would pull out an x from 3x to the fourth, that leaves me 3x cubed. From 6x cubed is just 6x squared. From negative 3x squared is just 3x. And the thing that would multiply to give me 2x would just be 2. Okay. So that's the first kind. You've already been doing it. It's just a matter of figuring out what you have to undistribute. The second kind is called factoring trinomials. Trinomials are often the product of two binomials. They're not always the product of two binomials. They're often the product of two binomials. The goal of factoring trinomials is to find the two binomials that made it. Okay? So here's a special note. Not all trinomials are factorable. Most of them are. The ones we are going to be working with, for the most part, are factorable. Although we will get to a point where we're going to have to write not factorable, and there's an alternate method to figuring it out. So to factor a trinomial, the first thing we're going to do is write two sets of parentheses under the trinomial. So in my example, x squared plus 6x plus 8, first thing I did was just write two sets of parentheses underneath of it. It's easy enough. It's two binomials. Alright, we're going to put the variable from the trinomial in each one. So I always look to my middle term, because that's exactly the letter that's going to go in here. So my middle term is 6, just plain x. So that's what's going to go right here, just the plain x. Alright, now I want to find two numbers that multiply to give me the last number, which is C, and add to give you the middle term, which is B. Remember A, B, and C? A, B, and C. All right, so what two numbers multiply to give me 8, but add up to give me 6? Well, 4 times 2 is 8, and 4 plus 2 is 6. So those two numbers go inside my parentheses here. So I've opened up the parentheses, I filled in the X, and then I found the two numbers that multiply to give me 8, add to give me 6, and those two go right here, along with their signs. So at that point, x squared plus 6x plus 8 is factored into x plus 4, x plus 2. Again, you can check your work. Simply distribute it back. And when you do that, you get x times x is x squared, x times 2 is 2x, 4 times x is 4x, and 4 times 2 is 8. Once you combine your like terms, sure enough, it works out. So yes, this answer, x plus 4, x plus 2, is the correct answer. I don't want you to get so wrapped up in doing this that you put this down as your correct answer, because this is what you started with. So a couple examples, and I've broken them down step by step. First thing I did was wrote my parentheses. Then I wrote my letter inside of each parentheses, and then I said, all right, what two numbers multiply to give me 12 but add to give me 7? I typically start with the factors of the last term. So 6 and 2, for example. If I said 6 times 2 is 12, but 6 plus 2 is 8, so that's not going to work. So another option, 4 and 3. 4 times 3 is 12, positive 12. These are both positive numbers. 4 plus 3 is 12. So 4 and 3 work perfectly. X plus 4, x minus 3. You will not need to write out each of those steps. Just for the purpose of the video, I've written it all out. So again, write your parentheses, x in the front of each one. Now, what two numbers multiply to give me negative 8, but add up to give me positive 2? So this is a little trickier with a negative at the end. So I know that I'm going to need a positive and a negative number. So 4 times negative 2 gives me negative 8. And then when I say 4 plus negative 2, or 4 minus 2, that gives me that positive 2 I was looking for. If I had written the negative 4 and positive 2, I would have ended up with negative 4 when I added them. So it wouldn't have been the correct combination. So I take my positive 4 and my negative 2, and I put them in those parentheses along with their signs. So, little note here, when that last term is positive, the signs of the binomials match each other and they have the same sign. So if you take a look, they have the same sign as the second term. So if you take a look, this is a positive number. Both signs are positive because that one is positive. When they are both negative, well, here's some more examples of that. Here we go. 4 times 1 multiplies to give me 4, but to get positive, they either both have to be negative or both have to be positive. Well, to add up to equal negative 5, they would both have to be negative. Here, I get positive 9. Well, positive 3 times positive 3 equals positive 9, and since I add up to get positive 6, so same sign, and it's that middle sign right there. These two have the same sign, and it's that middle sign right there. To get a positive at the end, the signs have to match. All right, so when the last term is negative, the numbers in the binomials will have different signs. The larger of the two terms will always match that middle term. So I've got negative 8 at the end. I come up with positive 4 and negative 2, and the 4 gets the positive because the 2 is positive. Negative 10, I came up with negative 5 and positive 2. Well, that was a negative 3, so the 5, being the bigger number, gets the negative sign.